Okay, so today what we're going to do is we're going to do lesson 7-7, which covers factoring special case polynomials. And then we're going to move into lesson 7-8, which is factor by grouping. And the reason I've combined both of these lessons is because the factor by grouping is almost a review of what I've already taught when I taught lesson 7-6. And so the only difference is that you may have to factor out a GCF before you do the rest of your problem, and that is factoring by grouping. So let's go ahead and start with 7-7. That's what pages 1 and 2 are for 7-7. And the first set of problems is all about being able to identify a specific type of problem. Okay, so when you look at a problem, you may not automatically realize, oh, my first and my third terms are perfect squares, and that's okay. If you don't realize it, you'll just factor it like you normally do. However, if you're able to easily recognize that both your first and your third terms are can factor out to perfect squares, then you can use the methods that I'm going to be teaching you on this page. Okay, so what does that look like? I'm looking at my first term, x squared, and I'm looking at my third term, 16, and I realize they're both perfect squares. So to write that out, I see that x squared, square root of x squared is x, and the square root of 16 is 4. Okay. And what I could do with that is I could write this out as, x plus 4 times x plus 4, or x plus 4 squared. Now, one of the things that you can do using mental math is just double check to make sure that this trinomial or this binomial here will multiply into this trinomial. Is you can take, and this is in step 2 here, determine if the middle term equals 2 times the square root of the first and the third terms. So what does that look like? That means that I'm going to take 2 times the square root of my first term times the square root of my third term. And if it equals my middle term, then this is a perfect square trinomial. 2 times x times 4 is 8x. Since that is my middle term, that checks out. And my answer is going to be x plus 4 squared. So let me go back a little bit and just review this problem. You want to see if the first and the third term are perfect squares. In this case, they are. To make sure that this is fully a perfect square trinomial, then you're going to take these two terms together and multiply them, and then multiply them by 2. And if you get 8x, then this is a perfect square trinomial. Sometimes your first and then your third terms will be perfect squares, but it doesn't equal your middle term when you multiply those square roots by 2. And so then it wouldn't be considered a perfect square trinomial. Now, I will tell you, some people think that this process is more complicated than just doing a regular factoring of a trinomial. And that's okay. You can still do factors of 16 that get you an 8 and solve it that way. Okay, I want you to go ahead and try practice 1 on your own. Okay, so for practice 1, we have the square root of x squared right here is x. And then the square root of 9 is 3. So in just looking at this, I can tell that my answer is going to be x plus 3 squared. But I want to double check and make sure that when I take 2 and I multiply it by these two terms, x and 3, that I get my middle term. 2 times x times 3 is 6x, so that checks out. So my answer is going to be x plus 3 times x plus 3, or x plus 3 squared. Okay. So let's go down to example and practice 2, where now we're incorporating a negative in here. Okay. So I can tell that both of these are perfect squares. The square root of x squared is x, and the square root of 36 is 6. And we need these to end up with a negative 12. So I'm going to take 2 times x, and then instead of a positive 6, it's going to be times a negative 6, and I get a negative 12x, which is my middle term. So in this case, my answer is going to be x minus 6 squared. Okay. All right, so just a recap on this one. Because there is a negative here, instead of being an x plus 6 squared here, it's going to be an x minus 6. Now, if this part confuses you right here, the whole multiplying 2 times the square root of the first and the third term, find the square root of each term, set it up like this, and then if you want to check your answer, just distribute the first term over here into the second term over here and see if you get what you started off with. Just do that whole checking system like I taught before. All right. Okay, so I'm going to pause the video. I want you to do practice 2, and then when I unpause the video, you will see the answer. Okay. Okay, so now that I've given you time to do practice 2, I'm going to go ahead and show you the answer here. If you're not ready, pause the video. Okay. And this is what you should have gotten. X minus 8 squared. All right, now we're going to move down to the next set of 4 where the first coefficient is not 1. Okay, so look at example 3. I know that 9x squared is a perfect square, and I know that 49 is a perfect square. So let's show our work. We have 9x squared. The square root of 9 is 3. The square root of x squared is x. And then we have the square root of 49, our third term, which is 7. So if I were to bypass this checking step right here that I was showing above, let's go ahead and write this out as 3x plus 7 times 3x plus 7. And I know that it's addition because every term is being added in the original problem. Now at this point, what I could do is I could distribute my 3x to this binomial and my 7 to this binomial, combine my terms, check, and see if I ended up with what I started out at. And so I'm going to do that. That's another way of just checking your work. So 3x times 3x is 9x squared. 3x times 7 is a 21x. 7 times 3x is a 21x. And 7 times 7 is a 49. So I can combine these like terms here. And this isn't new. This is something that we've already done. 9x squared, 21 plus 21 is 42x plus 49. And so I have, when I check, I have what I started with. So I know that this is correct here. And the way that I'm going to write my final answer, because they're the exact same terms, is 3x plus 7 squared. This is my final answer. So there's 2 ways to check your work. You can do what I showed up here by multiplying the square rooted terms by 2, or you could just distribute it back to check your work. Okay. Let's go ahead and do practice 3. We're going to find the square root of 25x squared and the square root of 16. So the square root of 25x squared is 5x. The square root of 16 is 4. So I have 5x plus 4 times 5x plus 4. And then to check it, I'm going to distribute it back. So 25x squared is 20x plus 20x plus 16. Combine my like terms. And I ended up with what we started with in our problem. So this checks out. And my final answer is 5x plus 4 squared. Okay, let's go ahead and move on down to example 4. If you have the hang of this, please pause the video, try these on your own. You are going to notice that there's a negative here, which means instead of having addition, we're going to have subtraction. Okay. So we're going to find the square root of 36x squared and 25. Now this time, instead of distributing it to check my answer, I'm going to go back up and do what I had done at first, just because to me that's simpler. And you can do this in your head. You don't have to write it out. But I'm going to take 2 times 6x times, and I'm going to make this 5 a negative. So I have 12x times a negative 5, which gives me a negative 60x, which matches that right there, that middle term. Okay, so let's put this together. We have 6x minus 5 times 6x minus 5. And our final answer is 6x minus 5 squared. Now, a lot of students will say, do we have to write it out like this first? No, you don't. I just do that so that when we're looking back at my notes, if anyone needs to look at them, they can see that the way that we got this was because we had these 2 terms. Okay. All right, I'm going to pause the video. I want you to try practice 4 completely on your own, and then you can come back and check your answer. Okay, so we're back, and I'm going to go ahead and show you practice 4. If you're not ready, please pause the video. So you should have gotten 7x minus 6 squared. All right, so on this page, we were working with perfect square trinomials and factoring those out. Let's go ahead and go to page 2, and we're going to see a couple of different types of problems here. The first set is called factoring a difference of 2 squares. So how do we get this term for this type of problem? So we're factoring. The difference is subtraction, and then 2 squares represents 2 terms that can be perfectly square rooted. Okay, so what we're doing is we're taking 2 perfect squares and we're subtracting them. That's how we get the difference of 2 squares. Okay. Here's an example. We found the square root of our first and second term, and then we put them together. And because it's the difference of 2 squares, one will be positive and one will be negative. Okay, and the step-by-step instructions are up here. So let's go ahead and work this first one out. We're going to take the square root of x squared, which is x, and we're going to take the square root of 25 here, and we get 5. And the way that we write this in is x plus 5 times x minus 5. And I'm going to show you why we end up with out a middle term, right? We have our first and our third term, but we don't have that middle term. Because when you distribute, we have x times x, which is x squared, x times a negative 5, which is negative 5x, 5 times x, which is a positive 5x, and 5 times a negative 5, which is a negative 25. And then when we combine our like terms, we have a negative 5x plus 5x. Those cancel out and we have a 0 there. So we're left with x squared minus 25.
Teachers, pardon the interruption. Please dismiss the high school baseball team to load the bus. Thank you.
Which is what we started with in our problem. Okay, so this checks out. So our final answer is right here. The difference of two squares. Okay, before we go to the practice, I want to do example 6, and then I'm going to pause the video and let you try practice 5 and practice 6 on your own. Okay, so let's look at example 6. We're going to take the square root of both our first and last term. So square root of 64x squared is 8x. And then the square root of 81 is 9. So we can write out our final answer as 8x plus 9 times 8x minus 9. And we can go back and we can distribute to see if we ended up with the right answer. And the right answer meaning if we end up with what we started with at the top, then our answer checks out. So 8x times 8x is 64x squared. 8x times a negative 9 is a negative 72x. 9 times an 8x is a positive 72x. And 9 times a negative 9 is a negative 81. Our negative 72 and positive 72x cancel out. So we're left with 64x squared minus 81, which is what we started with. So this is correct. Okay. All right, I would like for you to go ahead and try practice 5 and practice 6 on your own. Okay, I'm going to go ahead and show you the answers to practice 5 and practice 6. If you're not ready, please pause the video until you are. Okay. Now, we're going to go down to the bottom 4, and then after this page, we'll be done with lesson 7 and we'll move on to lesson 8. The bottom 4 is just the same as the top 4, except one addition. You have to factor out the greatest common factor first. Okay, so let's look at 7. We need to figure out what the greatest common factor is between 45x squared and 20. Well, I know that it's 5, so I'm going to divide both of these by 5. And I will rewrite my problem as 5 times 9x squared minus 4. Then we will factor these two differences of two squares because 9x squared is a perfect square, 4 is a perfect square. So over here we have 9x squared equals 3x. The square root of 4 equals 2. So that creates a difference of two squares. And we would write our final answer as 5 times 3x plus 2 times 3x minus 2. And then to go back and check your answer, you would distribute and then multiply everything by 5. Okay. So let's check to see if this is correct. We have 3x times 3x, which is 9x squared. Then we have 3x times negative 2 is a negative 6x. 2 times 3x is a positive 6x. 2 times a negative 2 is a negative 4. Combine our like terms. That becomes 0. So we have 5 times 9x squared minus 4. And I'm running out of space. But then we end up with, we're going to multiply our 5 times both terms. 45x squared minus 20. And that's what we started with up at the top. So that checks out. So then this right here is our final answer. Okay, let's go ahead and try example 8. And then I'm going to have you do practice 7 and 8. So let's do example 8. The greatest common factor on this one is 7. Okay. So we end up with 7 times 4x squared minus 9. Now at this point, you may no longer have to show the notes here that you're square rooting both of them, but I'm going to keep doing this. We have the square root of 4x squared as 2x and the square root of 9 as 3. So now we have 7 times 2x plus 3 times 2x minus 3. I want to go back and I want to check to make sure that's correct. So I'm going to distribute. 2x times 2x is 4x squared. 2x times a negative 3 is a negative 6x. 3 times 2x is a positive 6x. And 3 times a negative 3 is a negative 9. And we can't forget the 7 on the outside. We combine our like terms and that becomes 0. So we have 7 times 4x squared minus 9. And we distribute the 7 and we end up with 28x squared minus 63, which is what we started up with at the top. Okay. So this is our final answer. Okay, so I would like for you to try practice 7 and practice 8 on your own. So I'm going to pause the video for a moment and then we'll check our answers. If you want a hint for practice 8 before I show you the answer, the greatest common factor is 6. So you should have been able to divide 150 and 384 both by 6 to pull out that GCF. All right, right now I am going to go ahead and show you the answer for both practice problems. Okay. Go ahead and check your work. If you need to maybe go through it and see how we got the answer we did, you can go ahead and pause the video to do that. But right now we're going to move on to lesson 7-8. All right, and that is on page 3. Okay, here we go. This is all to do with grouping your polynomials together so that you could factor them. Okay. Now, by this point, you already know how to do this, but we're going to go ahead and we're going to go through the steps just to solidify the concept. If you feel like you could do this on your own, by all means do so, and then just check your answers as you go. Okay. So the first thing that we're going to do, step 1, is we're going to separate our polynomial into 2 groups. So I'm going to leave mine here, and I'm just going to group them like this. Okay. Some people will sometimes switch their numbers around, and that is okay. If you do that, you just have to make sure that if there is a negative in front of it, you take the negative with that number or that term. Okay. So I'm grouping my numbers. Step 2, determine the GCF of each group of 2 terms, and then you have to factor them out. So the greatest common factor here is 2x squared. And the greatest factor here is 3. Okay. So when I write this out for my first term, I have 2x squared. And then I divide 2x cubed divided by 2x squared is x. 12x squared divided by 2x squared is 6. Okay. Then I take out my GCF and it's a positive 3 that goes out here. And then I divide. 3x divided by 3 is x. And 18 divided by 3 is 6. Your goal is to make sure that these 2 factored out terms are the same. Okay. Now what I'm going to do is I'm going to rewrite my answer. I'm going to take 2x squared and 3. Those become 1 binomial. And then x plus 6 becomes another 1. Okay, and then this is my final answer. And if you want, you can distribute it all back together to check to make sure that when you distribute this, that you get this up here. Okay. All right. Let's go ahead and go down to example 2. We're going to do the same thing. We're just going to group. We're going to factor, and then we're going to put our answer together. So the first thing we're going to do is group these 2 terms together and then group these 2 terms together. You want to make sure that whatever sign is in front of this third term goes into the parenthesis with it, because that tells you whether or not you're going to factor out a negative or a positive number. Okay. So I'm going to divide this by my greatest common factor, which is going to be 5x squared. And I'm going to factor here. Oh, I don't see a greatest common factor. So if you don't see one, you still have to factor something out. We can factor out a 1. Okay. So let's go ahead and write this out. We have 5x squared is our greatest common factor. And when we divide 15x cubed divided by 15x squared gives us x. And then 40x squared divided by 5x squared gives us 8. And then here we factored out a 1, a positive 1. 3x divided by 1 is 3x. And 8 divided by 1 is 8. And I messed up. I could tell. Over here I messed up. So 15x cubed divided by 5x squared is a 3x. Okay. All right. Now I'm going to put my answer together. These 2 go together, and then these 2 go together. So my answer is 5x squared plus 1 times 3x plus 8. Okay. All right, let's go down to example 3. I'm going to group. Then I'm going to factor out my GCF. In my first set, I'm going to factor out a 2x squared. And then over here, because this first number is a negative, I'm going to factor out a negative, and it's going to be a negative 5. All right, so let's take those out. We have 2x squared. And then we have 2x cubed divided by 2x squared is just x. 12x squared divided by 2x squared is 6. And then we factored out a negative 5. Negative 5x divided by negative 5 is just x. Negative 30 divided by negative 5 is a positive 6. So now we're going to put our final answer together. 2x squared minus 5 times x plus 6. All right, let's look at the last example, and then I'm going to have you do the practice problems on your own. I'm going to group my binomials and factor out the greatest common factor. So in this case, it's going to be 9x squared. And for this one, it's going to be a negative 4. Remember, if the first number is a negative, take out a negative. So we have 9x squared. And 18x cubed divided by 9x squared is 2x. 45x squared divided by 9x squared is a positive 5. And over here, our greatest common factor is the negative 4. Negative 8x divided by negative 4 is a positive 2x. Negative 20 divided by negative 4 is a positive 5. And we can go ahead and put our answer together. 9x squared minus 4 times 2x plus 5. If for some reason these numbers right here don't end up the same, then you may have done something wrong and you want to go back and check your work. If you didn't do anything wrong, that just means it can't be factored any further that way. All right, so that's how you do these. I'm going to go ahead and pause the video, give you time to work on practice 1 through practice 4, and then we'll check the answers. Okay. Okay, so here I'm going to show you one practice at a time. So here's practice 1. We had a greatest common factor of 5x squared and 2, both positive. And then here's practice 2. Over here, this second term or second binomial, we could only factor out a 1. And it was very similar to the example 2 that we did. Okay. And then we have practice 3. On this first binomial, we could only factor out an x squared. We couldn't factor out a coefficient. And then we had to factor out a negative term because our first term was negative. So you can see all the different variations that we encounter when we're factoring out trinomials. And then here is practice 4. Okay. All right. So if you need to stop and go back and look at some of these before we move on, please do so. Otherwise, I'm moving on to page 4, which is more grouping. If you would like, actually, no, I want you to do these with me, because when we're factoring out with grouping, sometimes we have to take out a GCF. In this case, if you look at example 5, we can take out a 4, a GCF of 4 on all of those. Okay, so I'm going to factor out my GCF. So I'm going to take out a 4x. That's the greatest common factor between all 4 terms. And I'm going to rewrite it as 4x. And when I write out the problem, I'm going to go ahead and group it as I go. So 4x to the 4th divided by 4x is x cubed. Negative 8x cubed divided by 4x is negative 2x squared. That's one group. 12x squared divided by 4x is 3x. And negative 24x divided by 4x is negative 6. Okay. Okay, so now we can go ahead and factor by grouping like we did on the previous page. You just can't forget to keep this 4x and bring it with you as you go. So I'm going to have my 4x over here. And in this term, I can only take out an x squared. That's the greatest common factor between these 2 terms. And over here, I'm going to take out a 3. So I have x squared times x minus 2. And then I have a 3 times x minus 2. So notice I brought this 4x with me. I can't leave it alone. Either that or just remember to include it in your final answer. So the final answer is going to be 4x, which is the greatest common factor of the entire polynomial, times I have x squared and 3. And then times my x minus 2. Okay, let's go and do example 6. What I would like for you to do for example 6 is to factor out your greatest common factor and then group them, and then we'll pick up from there. Okay, so for example 6, my greatest common factor was 5x, and then I divided the entire polynomial by 5x, and I got x cubed minus x squared plus 4x minus 4, and then I grouped them. Okay, so that was about my first 2 to 3 steps there. Now we're going to treat this problem like we did on the previous page, and you're just going to factor each binomial here. So we can take out the greatest common factor of x squared in this set and the greatest common factor of 4 in this set. And we can rewrite our problem. Now, when I rewrite this 5x, I put it in parentheses so I don't get it confused with my x squared here. So we take 5x, and then we have x squared times, and we're going to divide those. We get x. X squared divided by x squared is 1, so minus 1. And then we have our 4, it's positive, and we end up with x minus 1. A lot of times students will want to multiply 5x times x squared, and you don't want to do that, okay? That wouldn't make it completely factored. Okay, so our final answer, we're going to take this 5x times x squared plus 4 times x minus 1. Okay. And this is our final answer. This one. Okay, before we move down to these 4 down here, 7 and 8, I want you to try practice 5 and practice 6. Okay. And then we'll come back and check our answers. Okay, here are the answers to, well, here's the first answer to practice 5. So I took out the greatest common factor 4. There were no variables to take out. And that's a 3 right there. And then I went ahead and factored it out like I did before. And then here is the answer to practice 6. I was able to pull out a GCF of 3x from the whole polynomial before I factored by grouping. Okay, we are now going to look at some different types of situations. You'll see that the next 3 are all trinomials. But the process is the same. You're going to factor out a greatest common factor first, then factor the trinomial as we have in the past. So let's look at example 7. The greatest common factor here, some people may look at this and say, oh, well, there's not a greatest common factor because 144 isn't divisible by 9, but it is. So in this case, this entire thing can be divided by 9x, okay? And when we factor this out, our GCF goes on the outside of our parentheses. 9x cubed divided by 9x is x squared. Negative 90x squared divided by 9x is a negative 10x. And 144x divided by 9x is a 16. Okay, this is a perfect example of how x squared and 16 are both perfect squares, but it will not, the middle term of negative 10 will not fit with that perfect square trinomial situation. So that's why we need to go back and check it. But we're going to go ahead and factor this like we have in the past. Since we have a coefficient of 1 for our first term, it makes it easy. We're just going to find factors of 16 that will give us a negative 10. So we have 1 and 16, 2 and 8, and then 4 and 4. It looks like the only one that I can see is going to be the 2 and the 8. And they both have to be negative. So negative 2 times negative 8 is a positive 16. Negative 2 plus a negative 8 is a negative 10. Okay. So our answer is 9x times x minus 2 times x minus 8. And then you could always go and distribute that to see if it checks out. Okay. Okay, let's do example 8 here. The greatest common factor is just an x. Okay, that's all we can take out of this one. So we have X. And then okay, now we're going back to factor by grouping in just a minute. So we have to find factors, and this is all review. So we have to find factors of 6 times 15 that will give us a 19. 6 times 15 is 90. So let's see, it looks like it's going to be 9 and 10. So 9 times 10 is 90. 9 plus 10 is 19 right here. Okay. So if you remember, this goes back to lesson 7-6. We're going to replace our 9 and our 10, 9x and 10x with 19x, because 9x plus 10x equals that 19x. And then we can group and we can factor. So when we write this out, we still have this x on the outside. We still have 6x squared. We're just replacing the 19x with 9x plus 10x. And then we have our 15. Okay. And now we group them. It's like we did above in the rest of these notes. So we group them. Now we're going to take out the greatest common factor. The greatest common factor here is 3x. And the greatest common factor here is 5. Okay. So we have x over here to the side. And we have our 3x that we factored out of our binomial. And 6x squared divided by 3x is 2x. And 9x divided by 3x is 3. Then we have the GCF out of the second binomial. So positive 5. 10x divided by 5 is 2x. 15 divided by 5 is 3. So these are the same. So now we're going to write out our final answer. X times 3x plus 5 times 2x plus 3. Okay. All right. I want you to go ahead and try practice 7 and practice 8 on your own. Okay, so here's practice 6. We factored out a 4x, leaving us with a trinomial that had a beginning coefficient of 1. So that factoring was a little bit simpler. And then we have practice 8. We could only factor out an x. And then we had to factor out the trinomial beginning with 3x squared. And those are the answers we get. Okay, we're going to do the very last 2 problems of our notes. Okay, just a few word problems. So is it determine the length and width of the square with the given area. Now, they're giving you the area here. And they want us to say what the length and the width is. Well, something that you should know about the area of a square is that the length equals the width. So another thing you should know is that it is, if you take the side and the side, it's the side squared. Okay, so the area of a square is length times width, or side squared. Knowing that, we should be able to factor this perfect square trinomial out to get what your length and your width is. So let's write it out over here. And instead of t, I'm going to use x. So we have 4x squared plus 36x plus 81. Going back to our 7-7 notes, I know that 4x squared is a perfect square. That's 2x. I know that the square root of 81 is 9. And then if I wanted to check, I could take 2 times 2x times 9. I get 4x times 9, which is 36x. That equals my middle term. So I would write my final answer as 2x plus 9 times 2x plus 9, or 2x plus 9 equals the length and the width. Okay. Now, normally we would write it as 2x plus 9 squared, but the question is asking to determine the length and the width. Well, the length is 2x plus 9 and the width is 2x plus 9. Okay. All right, let's look at this next one. The area of a square parking lot is 49 p to the 4th plus 8 p to the 2nd plus 36. Again, we're starting off with a perfect square trinomial. Okay, so the square root of 49 p to the 4th is 7p squared, and the square root of 36 is 6. So let me check to see if that will work. I'm going to have 2 times 7p squared times 6. So 2 times 7p squared is 14p squared. And 14p squared times 6 is 84p squared. Okay, I forgot. There was a mistake in this. This should be an 84. Okay, so change that to an 84. All right, so the way that we would write this would be 7p squared minus 6 times 7p squared minus 6, which equals 7p squared minus 6 squared. But let's see what they're asking for. It says find the length. Okay, well, the length equals 7p squared minus 6. All righty. Okay, so that concludes lesson 7-7 and 7-8. I know the notes are long, but it's because it's 2 lessons combined and I had a lot of practice in here. So if you have any questions, please come to help class or email me.